Here's part 2 of our missing lecture. So first 15, I hope you took a break, grab something to eat, drink, whatever it is. It's the best part of these. So the second half goes a little bit quicker because we're kind of on a roll. Things that we did last time was we did a secant line from 2 points, and then we did the tangent at each end point of that secant line, and we're kind of comparing them. And the last thing that we did is we looked at the slope of the tangent lines and then a secant line on a particular curve. If you want to think about it, we were looking at their negative, how steep they are. The bigger the number, the steeper it is. We talked about how at the bottom of a peak or at the top, at bottom of a valley or at top of a peak, the slope goes to 0. That tangent line, the derivative, is 0. If you notice, I use those words interchangeably a lot. Derivative meaning tangent line slope and back and forth. You really want to get to the point where you think of those as being the same thing, because they are. They're comparable in all ways. So x to the 3/2. Got to pick your graph, and hey, I'm figuring out your graphing calculator out, and you found that, yep, that's the one right there. So we'll skip that part. It says average rate of change from 1 to 16. I'm going to at least ballpark it. We're saying from here, kind of here to the end, we're going to see average rate of change would be the secant slope across here, just like that. And then eventually it's going to ask us for tangent slopes at each of those respective spots on there. And we can kind of just say, hey, it looks like they're all going to be positive. The one at x equals 1 is not as steep. So this one down here would be less steep, and the one up top would be more steep than the average rate of change. So as we're getting our values, that's our means of comparison, things we're looking for. Now, x to the 3/2 is kind of a cool derivative, and it's also just a cool function in general. But if I'm doing the average rate of change, you put in the 16 first, up top there, and you put in, this is average rate of change, the one. Remember, there's no calculus in this. It's just me getting that slope, change in y over change in x. If I put 16 into a 3/2, you can use your calculator, but there's a quick way to do it as well, and then 1 into 3/2. And then we put it over top of 15. 16 to the 3/2 would be good to remember what that stands for. That's the same thing as 16 to the 1/2 power, which is like a square root to the third. And then 1 to any power is always 1, so that's no big deal, over 15. And the inner part there, I'm going to go ahead and get blue again. This right there, square root of 16 is 4. So really what we're doing is just, hey, 4 to the third minus 1 over 15. Here, click, 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 you can hear my calculator. I mean, if you need that, great. 4 to the third minus 1, hit enter, I get 63. So 4 to the third, 64. And then divide that by 15. I'd rather not, to be honest with you. I'm just going to write 63 over 15. The only reason I might divide those is I kind of don't have a sense of what that scale is. It's actually equal to 4.2. So if you need that, I like it just because that gives me a sense of how steep that secant line is that I drew. So my secant slope is 63/15, so you can type that in. But it's about 4.2, and when I look at the picture, I'm going, okay, yeah, that secant blue slope, 4.2 sounds reasonable. Now, when I look at the derivatives at those spots, I can kind of compare and see how reasonable those are. The derivative of x to the 3/2 would be, bring the 3/2 out front, x, and then you would subtract 1 from 3/2. And I noticed that there were some problems with subtracting 1 on a few of your quizzes. So when you do subtract 1, you want to make sure it's common denominator. 3/2, you take away 2 over 2. So you'd get 3 over 2 times x to the 1/2 now. And that means now I can plug in 1. So f prime of 1, that first one, would be 3/2. Should we take that on here? That'd be 3/2 times 1 to the 1/2. 1 to anything is 1, so it's just 3/2. Okay, so we're thinking that's a slope of up 3 over 2. 3/2 is also 1.5, so it gives you another kind of perspective on what that is. Okay, just helpful hints to think about. 16, when you put it in there, f prime of 16 would look like 3/2 times 16 to the 1/2 is like square root of 16. So we're talking about 3/2 times 4, and if you aren't comfortable with fractions, your calculator will do just fine, but it's a good thing to know how to do. 3/2 times 4 would be the same thing as 12 over 2, or 6. And if I look at my graph, does 3/2 for my first tangent slope seem reasonable? For this one, I'm going, yeah, it's not bad. Does let's get another color going on here. So that's that bottom one here. Yep. Does a slope of 6 seem reasonable for the upper tangent? You look at it and you go, well, if my secant slope was 4 and this is 6 for my tangent slope, yeah, I'd say those are reasonable. The tangent looks steeper than the secant slope. Okay, moving on. Down below, we got all this cool data that says, hey, use your calculator to model this situation. I'm going to come back to that one a little bit later, and I don't know how much comfort you guys have with certain technologies, but I'm actually going to use Excel when I get a chance here, and we'll see what it does for a regression equation, and then I'll also show you some other tools that do cool stuff like that. But before I get there, I'm going to do a quick little introduction to what's called the product rule. So first, let's talk about what we do know. We have done what's called the power rule so far, and it's so powerful that it was even able to let us do this problem right here. If you have something to some power and a number out front, this is perfect power rule territory. And the way it's worked so far has been pretty simple. F prime of that situation would be you bring the 2 out front, make it 2 times 3, which is 6. You leave the 7 minus x in there, and then you reduce the power by 1. And then I've been mentioning in passing that you then take the derivative of the inside right there, and the derivative of that 7 minus x, did you know is negative 1? Because that negative x, the derivative is negative 1. It's the first time the derivative of the inside was something other than 1, which I think is kind of interesting. Okay, so that does make a difference in this case, because that negative 1 really changes things. So there's my derivative. That's fine as is, but I think for clarity, I would like to do, I'd like to clean that up a little bit so I can use it, because it says find the slope of the graph. So at a given point, which means I'm going to put 7, the x coordinate, into my derivative and see what I get. So before I do that, I'm going to clean this up and say f prime of x, and I'm going to distribute, I'm going to call this negative 6. I'm going to put those two together. Negative 6 times 7 minus x. I'm going to distribute the negative 6. And so what I'll get is negative 42 plus x. Because I distributed negative 6 times a negative x will give me a positive. I think I said x, but I meant 6x. So there you are. Now I'm ready to use it, take off, and get some values. I'm going to put 7 in there. So f prime of 7 will be negative 42 plus 6 times 7. Okay. I think I know what that is. That's negative 42 plus 42. We get 0. And there you have it. Put 0 in and you're home free. Power rule, one we know. Now we're talking about the product rule. And I'm going to leave plenty of room here. The product rule is new, and it only takes a second to master, so you guys are going to be fine if I just show you this ever so fast. But what it is, so go ahead and get yourself into that magic note place. The product rule is how we take the derivative of products. Now, if you recognize that, hey, I could distribute that out, I can multiply x minus 9 times x plus 5 and make it a polynomial and take the derivative, you are right. We could actually do some algebra and just make this a nice polynomial and take the derivative like we always have. That's great, and we will do that. But I also want to introduce a new rule and show you it still works as well. Here's how the product rule goes. If you've got some function h of x is equal to the product of g of x times f of x. Okay, those are just symbolic notations for, product. Then h prime of x, you got to make room for the product rule. A lot of us make the mistake of thinking the derivative of two functions multiplied, you just take the derivative of the first times the derivative of the second, and that's not true. It actually requires more than that. So you got to set up the little template for product rule, and once you do that, you're good to go. You actually have 4 components in the product rule, and they are g prime of x. So you do take the derivative of g for sure, but first you multiply it by plain f of x, no derivative, and then you take the derivative of f prime of x times plain g of x. So you have to do the derivative of the first function times the second unchanged plus the derivative of the second times the first unchanged. And if you want to write those words out, go for it, or look up some other examples, great. But for our example, we have one running right now. So if I do f of x, this is that, was that problem number 6 right there? X minus time times x plus 5. F of x equals x minus 9 times x plus 5. you can think of those as our two functions. So when I do f prime of x, I'm going to set up all my little boxes here. 4 components to every product rule. Bam, 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 bam. Just like that. And so if you remember, the first one is the derivative. So I'm going to highlight them as I go along. G prime of x, I'm going to do that first. Okay, so that's going to be the derivative of the first. Hey, that's just 1. The derivative of x minus 9 is 1. Times the second unchanged, f of x, don't even touch it. Don't even touch it. Okay, x plus 5. So if you're not sure what I'm looking at, I'm considering g of x, my first function, and I'm considering f of x here as my second function. And so I'm taking the derivative of g of x first, times the second unchanged. Now I'm going to take the derivative of x plus 5, which is also 1, times the first function. Sorry, times the second. Oh yeah, the first one unchanged. See? So each function gets derived, the derivative here, and it gets its derivative here, but when you're doing that, you have to multiply by the other function next door to it. It's pretty slick. We're done, actually. That's all it is. Obviously, 1 times x plus 5 is pretty simple. So I might simplify that, and 1 times x minus 9. Let's clean it up. This is just cleanup mode. You get x plus 5 plus x minus 9. Oh, we can put those together. Why not? 5 take away 9 is negative 4. You get 2x minus 4. Bingo, that is your f prime of x. Love it. Okay, now what's interesting about that is that if I had originally just distributed all this and FOIL it out, I'll get the same thing. So I've done some algebra ahead of time. Pardon my rapid run through this, but it would be 3x cubed plus 7x squared plus 3x plus 7. And then if you take the derivative of that, so that would be my f prime of x would end up being, what, 9, 3 times 3 is 9, x squared. Got it, you got it, you got it. I'm going to come back to that here in a minute. Did I put the wrong one on there? I knew I was on the wrong one. Here, come back to that one. Can you make that number 7? We're going to do that one next. I filled out the wrong one, and you totally saw it, didn't you? You can laugh about that. Okay, so next time I won't look away. But here's g prime. If I multiply out g of x, sorry about that, I went to the wrong one. Saying, wait a second, why is that so huge? But if I do x times x, it's be x squared plus 5x minus 9x minus 45. You do math all day long, you kind of just keep going autopilot. And that simplifies a little bit. But if I just take the derivative of it as is, you'll see it works out just like the last one. 2x, what is it, plus 5 minus 9. The derivative of 45 is 0. And then the 5 minus 9 makes 4, just like we had before. So g prime of x equals 2x minus 4. Okay, that is me doing some algebra to get to my derivative in that number 6. And over here, we did the product rule to get that same thing. So that's just justification that says they're the same. And I apologize, what I did before here is I just started the wrong problem. I wasn't paying attention, so if I delete that stuff out of there, just kind of working blindly. Okay, there's my warning to stop. And that's a healthy stopping place. So we'll start up another one here shortly.